we are going to go back to Algebra 1 again. Okay. You don't need your computers or your calculators until we get to the other side of our break. So, with systems of equations, remember the good old days when you would, I don't know if you call them good old days, but the days you had to do substitution, elimination, and graphing. Okay. What we were looking at is we were looking at where two lines intersected. Okay. So our answers were always going to be in ordered pair. Sometimes we ran into some issues where there were parallel lines, which means no solution. They wouldn't pass each other. We ran into a situation where it was the same line. There was infinitely many solutions. Okay. We did substitution, we did elimination to be able to figure out where they intersect. Okay. So now we're dealing with quadratics. So we're going to have a situation where it can cross in two places. Okay? We can have a situation where it crosses in one place. No places. Okay? Now it can't be the same line because then it wouldn't be a line in a quadratic. But if it is a quadratic and a quadratic, then it could be the same equation. Okay? So the only way you can do a linear and a quadratic is by substitution. Okay? You got paper? So, if you remember, we have to get a variable by itself. Okay? And why did I choose y? Because I'm going to plug it in here. Okay? So I'm going to move this x over. And now I have two equations that both equal y. Well, if they both equal y, isn't it the same argument that they equal each other? Okay? So now I'm going to set them equal to each other. So I had two equations, two unknowns. Now I'm down to one equation and one unknown. So I can solve that. Okay? So you are going to have a full-blown lesson on how to factor again in the second part of chapter 4. Okay? But I'm going to get your feet wet a little bit with remembering how to factor. Okay? So I'm going to set everything equal to 0. I'm going to move all of the stuff from the left side to the right side, only because I like to leave my leading coefficient, the number that's in front of the highest exponent, leading, it's the beginning, to be positive, okay? So I don't want to move all of this stuff from the right side to the left, then I'm dealing with a negative number. So I'm going to move everything from the left to the right. Okay, so if we remember back, I want to factor this. I have two numbers that multiply to get 4, but add to get -5. What are those two numbers? -1, -4. So remember, we want two numbers that multiply to get your C term, but add to get your B term. Okay? So, because we are in honors, we are going to do the shortcut as much as we can. Okay? You were in my CP class. I teach you one way of factoring, and that's it. Still going to teach you that one way of factoring, and you can use it every time if you feel comfortable doing that. But if you can catch on to the shortcut, use it when you can, okay? What I mean by that is, my leading coefficient is 1, right? Since it is 1, and I found my factors, I just got to simply put them in parentheses. So I can put x minus 4 and x minus 1. Okay, so back in Algebra 1, you might have learned how to factor by grouping, okay? That would have been what I would consider the long way of doing things. So if you don't catch on to the fact that I can use the shortcut here, you're still going to find what two numbers multiply to get 4 but add to get -5. It's still going to be the same thing. But then you'll split apart the middle using those two terms. And then you would factor by grouping. Okay? This factoring works every time on any kind of factoring problem that can be factored. Okay? But then we would group the first two together. Your teacher might have used parentheses. I like to draw underneath so it doesn't mess anything up. Here I can take out an x. I'm left with an x minus 4. Here I can take out a -1, x minus 4. What do I see twice? X minus 4. What's left over? X minus 1. So that's, if I want to factor and I want to factor one way every single time, I would do that. But if you notice, I did a lot more work to get the same exact answer, and that's only because my leading coefficient is 1. So if your leading coefficient is something other than 1, we're going to do that method over there. Okay? So if we were to set these equal to 0, we get x equals 4 and x equals 1. What did we say our answers are going to be? Huh? Okay, so where we intersect, and what were those called? Ordered pairs. Okay, so I have the x value of both of my ordered pairs. I still need to find my y values of my ordered pairs. So I know the first part of my answer is 4, and my other part of my answer is 1. To me, this guy right here looks like it's going to make my life a whole lot easy to solve for y. Okay? What I mean by that is I can take 4 and I plug it into x. What do you get? If I plug in 4 right here, -4 plus 5 gets me 1. And if you need to put that actually in your notes where we're getting that, do so. If I plug in a 1, -1 plus 5. Now, not every single time you're going to get them where they are flipped like that, okay? That just happened in this problem, okay? 4, 1, and 1, 4. So that line and that parabola intersect at 4, 1, and 1, 4. There are a lot of steps in what we're doing today. It's nothing you haven't seen before, but I agree. There are a lot of steps with each one of these problems. Any questions on where I got something or how I came up with something? Okay. Just try number 5. Try number 5 all the way through. today to tell you I was like, Ash. So the good news with this problem, they're both already set equal to y. So I don't have to do that first step from the last problem. All I have to do is go ahead and start by setting them equal to each other. And then I'm going to move everything from the right to the left. I like to keep things positive. So I'm going to move the 4x and my 10. And I want to find two numbers that multiply to get negative 16, but add to get negative 6. What are they? Negative 8 and positive 2. Remember, I want to get a negative 6 in the end. So then from there, I'm just going to write x minus 8 and x plus 2. And then if I set those equal to 0, I get x equals 8 and x equals negative 2. Now, I know some of y'all are not at that point yet, so I'm going to stop there so you can figure out what your y values are. And I challenge you, well, not on this one, never mind. I was going to say, I challenge you to do it without a calculator. You should be able to do it without a calculator. The next one is the one I want you to do without a calculator. Don't do number 6, though, unless you want to. Okay, if I take 8 and I plug it in, 4 times 8, 32, plus 10, I get 42. Okay, if I plug in negative 2, 4 times negative 2 gets me negative 8, plus 10 gets me a positive. Okay. What I would encourage a lot of y'all to do, especially those of you who play school, in other words, you write down everything I put up here, and then you get home and you're like, I'm so lost. Okay. But then you wrote everything down. You did what you were supposed to. You played school. Okay. I would encourage you to go back through and write out your own steps on how to do these problems. Like step 1, set them equal to variable. Okay. Well, it's already done, so I don't have to do that one. Step 2, set them equal to each other. Step 3, move everything to one side. Step 4, factor. Step 5, set equal to 0. Step 6, plug it back in to find y. Okay, any of those little hints you can give yourself, do so. That will help you, and that will definitely help you remember it for the test as well. Okay, especially ones that have a lot of steps. Any questions with a linear function and a quadratic? Okay, because now we're going to look at a quadratic and a quadratic. Okay, we're going to approach these the same exact way. We're going to make sure they're both set equal to y, and then we're going to set them equal to each other. Same steps. Just a little bit of a different approach when solving. So this particular one, I'm going to subtract my x squared over. Now I can set them equal to each other. Again, I like to keep things positive, so I'm going to move everything from the right side over to the left. Okay, looking at this particular problem, is my leading coefficient 1? No. So I can't do the shortcut just by looking at this, okay? If I don't catch on to it, I would have to do multiply the A times the C. It was called the AC method, if your teacher called it that, where you would do 2 times 30. Then you would find factors of 60. They get you 16, which is pretty obvious, 6 and 10, okay? But if you notice, they're all divisible by what? 2. So what if I divided by 2 and factored out a 2? From everything. Now, inside the parentheses, do I have a leading coefficient of 1? Yeah. So now I can do the shortcut inside the parentheses. So what are 2 numbers that multiply to get 15, but add to get 8? 3 and 5. Okay. So when I say the next step was to set them equal to 0, we would have said x equals -3 and x equals -5. Looking at this 2, if we set 2 equal to 0, do we have anything to solve for? It doesn't mean anything to us, okay? That 2, when we're solving, it doesn't have any weight unless it has a variable, okay? If it was 2x, that's different. We would set that equal to 0, okay? But since it's just a number, it really doesn't mean anything to us right now, okay? So go ahead and figure out, without a calculator, what my y values are. Okay, so I kind of like the second equation better because I'm looking at having to multiply by 18 on the first one, and that's not really what I'm into. Okay, could I do it that way? Absolutely. Without a calculator, I might trust myself a little bit more to plug it into the second one. So if you want to use a -1, so then I could say -3 squared is a +9, but the negative that's in front of that makes that a -9 minus 6 plus 5. So -9 minus 6 gets me -15. -15 plus 5 gets me a -10. Okay. Again, get comfortable with doing things without a calculator. Your state test doesn't have it all the way through. The ACT does, but your state test does not. Okay. All right, so the next one, same thing. If I plug in a -5, so I end up with a -25 minus 10 plus 5. It gets me -35 plus my 5 gets me a -30. Okay. The more work you can show, the more credit I can give you in case you get those confused. Okay. A lot of steps, a lot of room for error. Okay. Little mistakes can mess you up, but the more you show me, the more I can help you. Because it could have been all the way at the beginning that you forget something. But if I can follow what you've done, then I can easily say, whoops, we made a mistake right there. Instead of missing 5 points for the whole problem, maybe you miss only 2 or something like that, okay? Better than all of it. Any questions on this? And that's a lot to come back to from Labor Day, okay? Let's go ahead and take a quick break. I don't think I can pause this, so if you are watching this recording, just hang tight, fast forward. And y'all take a quick break. 1. All right, let's go ahead and come back. You'll need your calculator. You do not have a calculator, get your TI calculator up and running on your Chromebook. If you want to take a picture of these steps, add them to your notes later, you can. Hopefully, at some point, you'll get to the point where it's natural. Seems like a lot of steps at the beginning, but once you start doing them, then it'll be a little bit more comfortable. And I'll post this video too if you just want to reference them later. You can do that as well. Okay, so how many of y'all have taken the ACT so far? A couple of y'all? Did you ever see on the ACT a box with floating numbers? Okay, there's something weird that looks like a box and then it had floating numbers. You're like, I don't know what you want me to do with that. Okay, that's a matrix. Okay, so what we're going to use a matrix for is to solve a system of 3 equations with 3 unknowns. Okay, so for example, I need to know what x equals, what y equals, and what z equals. I was tutoring a kid from Farragut yesterday. One of my friends, it's her stepdaughter. And she brought me out of retirement because I got done. I was not doing tutoring after school anymore. And then I was like, okay, I'll do it for you. But they are doing these by hand. There's a lot of work that goes into doing these by hand. Okay? You have to do elimination multiple times. For us, and what we've been doing at Hardin Valley is we've just been using our calculators and using the matrix. Okay? So, to make the matrix happen, we're going to use the coefficients. And it's very important that you keep x's in the same column, y's in the same column, z's in the same column, and your answers in the same column. Okay? So, for example, with this particular problem, this is a 1. So I'm going to go 1, 3, -5, -30. I'm just writing down the numbers that are in front of the variables. Those are called coefficients. And I have 5, -3, -4, 21. Then I have -6, but I don't have a y there, so I need to put a 0, a 2, and then a -12. Okay? Now we're going to follow those steps to do this matrix, okay? It's going to solve this equation for us. All right, so step 1, I'm going to go into second matrix. I'm going to scroll over to edit. If you already have something there, that's fine. You're going to override it here in a second. So you might be wondering, why does it say 3x4? Okay, we like Reese cups, right? Hopefully, unless you're allergic to peanuts. Reese cups, remote controls. Okay, RC Cola used to be a thing. All right, notice how I'm saying R and then C. Also my initials, Rachel Chapman. Okay, I'll help you remember as well. How many rows do I have here? 3 rows. How many columns do I have? 4. That's why you're going to see a 3 by 4, okay? So when you're over on edit, press enter. If you don't have a 3 there and a 4 there, just press 3 and then 4 and then enter. And you should see the matrix pop up of how it's supposed to look. Okay? Now go ahead and enter in your numbers. The only way you can mess up this problem is if you don't remember how to plug it in the calculator or you accidentally plug in the wrong number. So be careful once you plug it in to go back in, double check you plugged in everything correctly.
How do I go back to one if I mess up?
Do it.
How do you go back to one if you mess up?
Just use the arrows. Okay. Once you have your matrix plugged in, go to second quit. Go back into matrix. Go over to math. Now, I had a group of students that coined the phrase double ref for the next part. You scroll down, or you can actually scroll up. It'll take you less time. Notice how there's an REF and there's an RREF. We're going to use the RREF, what they call the double ref. But what it really stands for is the row reduced echelon form. You're like, so double ref. I'm going to stick with that. Okay. Row reduced echelon form. Press enter. Okay. Go back into matrix because you got to tell it, hey, I want you to calculate this for me on the matrix I just made. Okay. So second matrix, we put it in A. So I'm going to press enter. Press enter again. So something magical just happened. They did all the hard work for you. Okay? And what I mean by that is, try to do this down here. Oh, come on. Okay, so notice how 1, 5, and negative 6 were the coefficients for what? Come on. Come on. Like how to just have logos. I think so. Yeah. Okay. Uh-huh. Okay. 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 Yeah, I should be able to. The only thing is, hopefully I'll be able to log those specific things. It might be more, it might be less, it might be whatever. Okay. Okay, awesome. Okay, sorry about that. So, what coefficients does 1, 5, and negative 6 belong to? X, okay. Then 3, negative 3, 0 belong to Y. And then we have our Z column. And then we have our answer column. So here's the cool part. This diagonal set of ones with the zeros is what's called an identity matrix. The numbers that are on the end are your answers. So the first column was X. This is going to make it not show up very well. This is basically saying X equals 3. Y equals negative 6. And Z equals 3. So it's really cool that now has told us our answer. Okay, so again, the identity matrix, I'm going to do it where it's bigger. So basically it's saying if my x's were in this first column, this is saying 1x equals 3. 1y equals negative 6, and 1z equals 3. And that's what we want to give us our answer. If you did not get those numbers, go back in the matrix and double check that you plugged in all the correct numbers, okay? And it can play some serious mind games with you. So what I mean by that is I had a student in 7 a.m. that was like, I had looked at this 4 times. I entered in the right numbers. And she forgot the negative on the 30. But she looked at it 100 times and she's like, I swear, I put in all the right numbers. And then I looked at it and I said, oh, you forgot the negative on the 30. She's like, seriously? I looked at this 100 times, okay? So make sure if you're not getting the same answers that you're double checking which ones you plugged in. Yeah.
The right thing, because it's, you said hit math and then.
Go to second matrix first. And then under second matrix, go to math. And scroll. Okay, let's try another one.
When I enter it, what am I supposed to do next time I write down
So then this means x equals 3, y equals negative 6, and z equals 3. That's the answer. If the variable is not there, it's 0. If the number is not there, it's 1. Don't get those confused. Again, you can still do it in matrix A. All you're doing is overriding it by writing new numbers there. So you don't have to choose matrix B to make a completely different one. I'm missing a Z on the third equation, so I plugged in a 0. Once that's plugged in, second quit. If you're doing 100 of these, which you wouldn't be doing 100 of these, but if you are doing a handful of these, remember you can always do second enter. And I don't have to go back through the whole matrix, double ref, matrix, choose A, all of that. It does it for me, okay? So this particular one, we should get that x equals -1, y is 4, and z is 3, right? Yeah. Okay. The more you do of these, the better you'll get at it, because that's a lot of steps, especially in a calculator, okay? Go ahead and try number 10. Now, number 10 looks like a problem that I could easily just say, well, if y is 2, what's stopping me from plugging in 2 into this equation down here? Then I can solve for x. Then I have x and y. All I need is z, so I plug those in and solve for z. That you could do that as well, okay? Yes. Let's check it out. So you got 2, 4, -3, 5, okay? And you got -3, -5, -1. You have a -2. Because that's z. Again, they all have their own little ways to mess you up. You can do this for two equations, 2 unknowns, 3 equations, 3 unknowns, all of that, okay? You cannot, however, do it with the problems we were just doing with the x squareds, okay? That is not an option. Okay, so if I go back into matrix, edit my matrix, still a 3x4. I don't have an x. I have a y, which is 1. Don't get confused on that because you want to say y equals 2. Okay. 0 for z, and then a 2. If you are someone that is throwing them off, you can easily do 0x plus 1y plus 0z equals 2. You can write it out that way so you know when to put zeros in. Okay. Got my -3 already in there. Okay, 3, 2, 3, -6, 0, and 8. Okay, second quit. I can do second enter. And it tells me my x is 5, my y is 2, which it should be because they said y is 2, and z is 6. Okay, does anyone get anything different you want me to look at your calculator? So being able to do matrices in your calculator is going to help you a lot, especially on your ACT. Because they have them where you can add them together, multiply them together, all that stuff. And you would do that all in matrix. So it's pretty cool how that works. Like if I wanted to add two matrices together, then I would plug one into matrix A and one into matrix B. And then I would easily just do matrix A plus matrix B. Which in this case, it won't let me do it because the dimensions are off. But that's how I would do it in the calculator. So if you come across that on the ACT, that's how you approach those. Any questions on this? Okay. Let's look at some graphing examples. We're going to go way back to Algebra 1. All the way back. Okay, so when you saw less than or equal to or greater than or equal to, was that an open or a closed circle when you did a number line?
Close.
Closed because it equals it.
Yeah.
If it's less than or equal to or greater than or equal to, it equals it. So it's a closed circle.
Access
Ooh, it's get all the cobwebs out. Okay. So when we had a closed circle, that also meant we drew a solid line. So remember, your options are solid and dotted. So if it includes it, you want to make sure that line is solid. Okay? Which, if we had a less than and greater than sign, they're not equal to it. That was an open circle, which means we drew a dotted line. Okay? When we were graphing, we drew a dotted line. All right? If it was a less than or equal to sign and a less than sign, did you shade above or below? Think of less than. Above or below? Below. Think of less than. Has to be below it. Okay? So we would shade below the line. If it's greater than, we would shade above the line. Okay? Some of your teachers may have had you do a test point where you would plug that into the equation. If the inequality held true, then you would shade that area. This was like when y'all had to get your color pencils out. You had color. So here's my rules. If I give you a calculator on this part of a test or anything like that, you use the calculator. What I mean by that is, that doesn't count. Okay? My freehand drawers out there, that does not count. Okay? So if you're given a calculator and I say, hey, that's a resource for you, you are going to give me actual points for both of those graphs. Okay? You're not going to say it looks like that and, okay, cool, done. Give me another problem. All right? I want to see you actually plotting points and actually showing me what those points are. Okay? So, if you did not have a calculator, let's do this one as if we did not. Where do we start? Yeah. You start where? I'm sorry.
I think you start at
+3. Uh-huh. So that is our what?
Y.
Y-intercept. And then we have a slope of how much? 2. So up 2 over 1. And remember with systems of equations, you had to actually draw out all of these dots only because we want to see where things intersect. So if you only do like 2 or 3 of them and then you kind of freehand the rest of it, you wouldn't have been able to find the exact intersection point. So that's why you make sure to do all of it. And the good news is if it was a dotted line, you would be done with that because it's already dotted, okay? But in this particular case, we are equal to. So that needs to be a solid line. And before we get out our colored pencils, we don't need to shade everything. Which way are we shading, above or below that line? Below, it's less than. So I would shade below this line. So I'd probably just draw myself some little arrows so I wouldn't have to be coloring everything. And some of y'all would be coloring for hours, making it perfect and pretty, okay? The second equation is the one we've been doing this whole time. So if I do 0, 0, 1, 1, negative 1, 1, 2, 4, 3, 9, and so on, that's the parent function. I plug in 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, okay? It is equal to, so it's a solid line. And which one is this shaded? Above or below? Above. So that's everywhere inside the parabola. So it's anywhere inside here. So if you notice, my solution is where the 2 shading spots intersect. And that happens to be inside here. If you are someone that has chosen to shade both equations, that's totally fine. Just make sure where they intersect is really dark. And if you're still not sure about that, draw an arrow to that spot and say my solution. Okay? Don't leave any kind of guessing there. Whew, that was a blast from the past. Okay? Hopefully you can remember a lot of that stuff with the dotted solid and whatnot. Okay? So what if I give you a calculator as an option on this? Okay? So I'm going to show you in y equals how we can do this, but how I also want it done. Okay, so in y equals, let's go ahead and type those 2 equations. We'll do 2x plus 3 and y1. And then x squared and y2. And with this, I'm only able to share one screen, so I'm just going to drag these over for those of y'all watching this. Those of y'all tuning in at home. It's so weird. Okay. So if I go up to my first one, that one was what symbol? Less than, greater than? Less than. And we said we were going to shade below, right? Okay. And if you already know this trick, great, but some of us might not. So if you scroll all the way to the left and press enter, scroll down to where it says line, and then yours is going to be different. I'll come by and look at yours. Okay. Notice how the first option I pick, if I scroll over, it goes up. The triangle goes up in the air. That's above. Okay. If I press over one more time, see how it flips to the bottom? That's below. Okay, so the first one's above, second one's below. So then since you said below, I'm going to pick below. Okay, I'm going to press OK. Then I'm going to scroll down to x squared. Same thing, I'm going to press enter. I'm going to change it to where it's above. Press OK. And now I'm going to graph. Your calculator's still messed up from when we were playing with it. Zoom 6 always gets it back to normal. Yes, sir.
This is something that I did, but if you want to get like where you don't have to remember like the up and down of the line, if you go to apps, and then I don't know what it is, it's different from me than everyone else. For some reason I found, and you get the one that says any quals.
Okay.
You can do the same thing, but you can actually put the less than or equal to sign.
So I don't have it. So some people have the application and some people don't, right? He's like, so if you want it, $10 a pop, right?
It says finance.
The way I did it is I like put games online one time, and then afterwards like 37 different apps appeared, and I was like, okay.
You got spammed with apps.
No, but like they're really good finance. Like I think I got a periodic table on here now.
Man.
Can I take my calculator to Best Buy?
I just go to the computer.
Your new financing powers. You can buy.
Okay, so notice how if you were to plug this in the calculator and get that, I don't want to see. Oh, cool. It looks like that. There. Don't do that to me. If I give you a calculator, do not do that to me, okay? I want you to actually look at points. And remember, if you want to look at points, all you have to do is go to second table. That's all the points you need, okay? Plot as many as you can. Make it as pretty as you can. Okay? When you're in y equals, and instead of going to the far left to fix it back to the line, all you have to do is when you're on your equation, press clear, enter. Scroll down, press clear, enter. Whoops. Clear, I think it was, sorry. Press clear twice, and then it clears it, okay? So then that way you don't have to go over to the side and change it back to a line, okay? So if you are given a calculator, you say thank you, you look at your table, you make it pretty, and you move on, okay? But if it's where you have to graph these by hand, that's going to be a little bit different. I want you to actually, you have to do a little bit more work on your end, but it should look the exact same, okay? Any questions on those? The blast from the past. Okay. I'll have y'all go ahead and get started on your homework.